Hello everyone. So today we will look at a sample of the final exam in the last semester, and we'll go over all the questions so you can see what we expect from the final exam. So let's hop on. We have two files here, one file for the blank exam and one file with the solution. So let's look at all the problems. So basically, like from Math 100, what we learned was in chapter 1, we look at the basic overview about statistics, right? All kind of terms and a big picture. And then in chapter 2, we start look at data visualize and also some of the way we use quantitative measurement to get the basic access to the data information. And in chapter 3 and 4, we start to learn how data distributed, right? And then we look at binomial distribution for the first case, where we look at the data in a systematic way for discrete data, and we use the binomial distribution to model that. And then eventually we move to continuous distribution, and we emphasize in the normal distribution. And then we look at the central limit theorem, which is the most important theorem in statistics history. And basically, like for the last part, which is 8, 9, and 10, which is 12 in the textbook, we look at the three pillars of statistics. The first one is estimation. We give how we can provide an educated guess for a certain parameter, like we say what the mean height of US people, right? And the second set, which is the set of application where we look at the testing perspective, right? So we have a certain research hypothesis and how you can use the data or collect data to support the research hypothesis. And lastly, which is prediction, the third pillar, where you try to use several random variables. So in our case, we just use one to predict another variable. So say you use something easy to obtain, easy to control to predict something it's hard to obtain, hard to control, right? So for example, the hours you sleep, you use that to predict the outcome of your final exam, right? So let's look at the final exam. Basically, it's include all 10 chapters, right? So we have 20 problems with multiple choices, and each problem, I think 25. Also here 25. So each problem works 4 points, and again, just whenever possible, try to show your effort, right? So this way, you can optimize your score. So let's look at the first question. 12 random classroom in UCC campus, random selected, and all students within those classes are surveyed for opinions on new university policy. So here we look at what is the type sampling here. So here, like for this problem, if you recall the type sampling, and you should know that, like basically here, like we have so many classrooms, right? But we just choose like random 12 of them, 12 classroom. And among 12 classroom here, what we do here, first you choose 12 classroom among maybe 100 classrooms, right? I don't have the exact number, but you just first choose like 12 classroom, and then after that, for each classroom, right, you survey all students. So the all here is the term you need to pay specific attention to. So basically, it shouldn't be convenience, right? It shouldn't be stratify, right? So B here will be a good choice because with the cluster sample, right? So basically, like you just choose some places and then you survey the whole, right? The whole block. So here will be a cluster, will be B. Here that you can look at the chapter 1 and to review different kind of sampling mechanism. So this is belong to the cluster class, assembling class. So here, like determine whether the data you recorded will be discrete or continuous, right? Number of students enrolled in UTC chemistry course. So it should be qualitative because it's number, right? Maybe 5, 6, 7, 8, 9, 10. It has to be quantitative, right? And then whether continuous or discrete. And then for continuous discrete, again, you ask yourself a question, right? Can you make it small as you want? So say, can we get like 7.1 or 7.2 student enroll in the chemistry class? And if the answer is no, and then it will decrease, right? You cannot chop to the level as smooth as you want, right? And because like the number of students has to be an integer, right? Integer. So here, like in this question, number 3, Laurie asked 24 students how many hours they have spent doing homework during the previous week, and the result is presented in a relative frequency table here. And what's the question here? What is the relative frequency of the class value between 12 and 13? So you just first look at like between 12 and 13, how many students you have, right? So here you have 7 students, right? So what the relative frequency? So relative frequency basically is defined by the frequency you divide by total. So here the frequency here is 7 for this class, right? So it will be 7 divided by the total. Here you survey 24. You can also add up all these numbers here, right? 3 plus 13 plus 7 plus 1 will be 24. So this will be 7 over 24. Then just plug in your calculator. Let me just quickly look at the solution here, which is 29.2%. Okay, 29.2. So if you plug in, you should get a 0.292, and which is 292, right? 29.2%. So which is the A, right? A will be the choice. So find the mean of the given probability distribution. I think, let me see. This is, we missed the table somewhere. I believe this page, we should have a table. Uh-oh. What is the table? I think we do have the table somewhere. Let me just quickly look at the word file. The word file. So here is no, let's see. Okay. I think here we do have a table. So let's look at this file. Okay, so here we have a table, right? So this table, basically you should have like the value of x, which is either 0, 1, or 2, or 3. And then you have the px, right? Probably x, which is probably x equal 0 is 0.66. Probably x equal 1 is 0.14. Probably x equal 2 is 0.15. And probably x equal 3 0.05. So the mean, so in this case, we do have formula, I believe in chapter 2, to calculate the mean for this discrete distribution, okay? Discrete distribution, maybe 4, yeah, I believe maybe 4 maybe the correct place. So basically the mean is defined by ax equal to, right, x I times pi, right? So this is the original formula, pi, I from 1 to n. So xi is each value, is discrete value. So here will be 0 times pi, which is probably x equal 0. So it will be 0 times 0.66 plus 1 times 0.14 plus 2 1.5, 0.15 plus 3.05. And if you add up them together, you should get the B, right? B. So this case will be mu equal to 0.959, okay, 0.59. So it will be 0.59. Okay, for this problem, 0.59. 0.59. So B, okay, so B will be the choice, correct choice here, B. 0.59. Okay. So we do have a table, right? We do have a table here. X and PX, right? We have a 0, 1, 2, 3. Let's see. Point 66, point 14, point 15. 66, 14, 15. 66, 14, 15. And 05. Okay, 05. And for sure, you also check that the summation and this right hand side should be 1, right? Because this will make it satisfy definition of probability distribution. In phi, the phi number summary, okay, which is mean Q1, Q2, median. I think it should be Q3. Mistake here. Which is 75 percentile value, and maximum here like that. Define which one should be outlier. So the way we define outlier is whatever less than Q1 subtract 1.5 interquartile range, which is the Q3 subtract Q1. So if you have such a point, data point, right? Or you have such a point bigger than this, right? We will call them outlier, okay? So here I basically select all apply, right? So if you plug in, okay, the Q1 is 68, Q3 is 84, Q1 68, and also 84, 68, right? And 68. Okay. So this is a cutoff, the lower cutoff value, upper cutoff. If you have some, you calculate this, you plug in your TI calculator, okay. So if you plug in, you should be able to get the upper cutoff will be 1. So here, like we calculate interquartile range first, which is Q3 subtract Q1, which is 16, and 1.5 which is 24. Okay, so just a similar, okay, but they break it down a little bit further for you to see it, right? So basically, like if you plug in your calculator, you should be able to get your lower bound here. This way will be 44. And the upper bound for the cutoff will be 108, right? 108. So something, if you have a data set, data point with a bigger, either bigger than 108 or less than 44, it should be outlier, okay? So 105, it not satisfy either this condition, right? 85 not, 65 not, 45 not. So here you have only E, right? Which is the 25, right? So this way you have one outlier, and it should belong to the low error region, right? The low cut up region. And then 6, at one college, GPAs are normally distributed between 3 standard 0.6 and using Pico rule. 65, I think it should be 68, right? It should be 65, it's wrong here. Typo here, okay. 68, 99, which is 68% of data for one standard from the mean, 95% 2, and 99.7 3, right? And find the percentage student have the GPA between 1.8 to 4.2. So from here you can see that the mean, because the mean is 3 and standard deviation 0.6, right? 0.6. So basically you can see that the 1.8 is just how many standard deviation below the mean here. So the 1.8 equal to 2 standard deviation below the mean, right? And the 1.2, which is a 2 standard deviation above the mean, okay? So you just calculate these curves, these two values. So this is in -2, which means 2 standard deviation below the mean. And this guy, which is 2 standard deviation above the mean, okay? So which means like it tells us like the 95%, right, of the data will belong to 2 standard deviation of the mean, right? Mu subtract 2 sigma and mu plus 2 sigma. So in this case, mu subtract 2 sigma basically just 1.8 and mu plus 2 sigma from 2. So the answer should be 95%, right? You can also draw the distribution normal to see this, right? So here the mean, which is 3, and 2 standard deviation above the mean, below the mean is 1.8, and 2 standard deviation above the mean is 4.2. So here basically you have like 95% of your data belong to this range. So basically for this type of question, you just calculate z score for the low bound, upper bound. You should be able to see that, right? See that. What is probability of guessing incorrectly a multiple choice? So incorrect, okay? Yes, incorrect. On a test, if the probability of guessing incorrect multiple choice is 0.8, what probability of guessing correct, right? So here, like, it's a complement event. Incorrect guessing a 0.8, which means correct guessing will be 1 subtract 0.8, which is 0.2, right? 0.2. Complement event. Okay. Here, let's see. In 8, on a statistics exam, 18 students receive A, 23 receive B, 8 students C, and 5 students F. Oh, the table is pushed down here. Okay. Here. Okay, this table here. But anyway, okay. We need draw it here. On statistics exam, 18 students receive A, 23 receive B, 8 receive C, 5 receive F. If a single student pick a random, what probability that they either receive A and B? So this is a event. So totally we have how many students we have in total? We have 18 plus 23 plus 8, right? Plus 5, right? So this is the sample size we have a totally will be 45, 53, 58, right? 58. And here we want to look at the event where a student receive either A or B, okay. So how many students receive either A or B? So which is 18 plus 23, right? So in this case, you have got to 45, 41, okay. So basically at the time, the probability you get, you randomly choose student, he or she receive either A or B will be just simply as 41 divided by the 58, right? 58. The total symbol event in this event, which is 41, divided by the total possible event, which is like the sample size here in this case, 58. So if you do that, let's see what the calculation here. We have 5, 6, 7 correct also, right? So is it 41 by 54? And if you do the calculation, it will be this E option, okay, E, which is 0.759, okay, 0.759, right? You can check with your TI calculator too, right? So see here, in 9, student A score 9.5 on a quiz at the mean A8 and selection 1.3, and student B score 84 on a test with the mean 75, selection 6.9. Find this score. So two tasks, right? And first, find this score to determine which student performed better relatively to his classmate. So you can see, like, because here, like, we compare two things different, right? Maybe student A, he do a test maybe in history, right? Student B, he do a test in statistics, right? But how do we know which one better, right? You cannot compare directly their score each other. Basically, you have to compare with their bulk of data. So this is why you need to calculate this score for each student, and then from this score, you can decide who did a better job, right? So for student A, this score for student A is that maybe I just put the A here. We 99.5 subtract 8.8, okay? And divide by standard deviation, which is 1.3. And the z score for student B, I put ZB, I didn't know ZB, with 84 subtract 75, right? Divide by 6.9, right? So if I do the calculation, this table is for problem number 4, okay? For some reason, it gets pushed down here. So here we just, I think, oh, no, this table, I'm sorry, this table, so it might belong to question 5. This is the correct one, belong to 10. So if you do the calculation, you should be able to get for 9, the answer will be 0.54 and B will be 1.3. 0.54 for A, 1.3 for B, right? So in this case, you can see that compare to the his her pool update bulk update that, right? Student A, he or she just like 0.54 standard deviation above the mean. While for student B, compared to his her bulk update that, right? He or she stand at the 1.3 standard deviation above the mean. So which means she did a better job, right? So the correct choice would be student B performed better. Here, the table below show incomplete probability density function is created random variable X. Number of times student has had to finance quiz until receive perfect score. What should be probability? B, mixing. Okay, so they're asking for the mixing, okay, value here. And what should in this mixing value should be. So basically, like here, we just look at definition of the discrete distribution. We require each observation type probability must be between 0 and 1, and the summation will be 1, right? So because the summation for all these cases will be 1, and you have like 3 cases, so basically the missing will be just 1 subtract whatever here, right? For 1, the summation of the remaining here, right? 2, 1, and plus for 1. And if you plug in your calculator, you should get something in with a 0.7. So I believe A will be correct choice. Yeah, it's A, right? So here just I do a kind of trick, right? Because I see the end of the 3 thing in the sum here will be 3. So 1 subtract, which I should get something n as 7, okay? So A will be correct choice. But I mean, if you want to confirm it, you can use your calculator too. Identify the parameter P in the following binomial distribution scenario. The probability passing the test is 0.768, failing at 0.232. Okay, pass plus fail will be 1, right? Considering passing the test to be success. Okay, so here success within passing. So I have like say, you know, what is the P, right? That's just a parameter for the binomial if you model that by binomial, right? So say, you know, you can think like for this statistics, right? Probably we get a C is at 0.76 and above, right? 8, and probably you get C and below is 0.2, D below, right? D will be 0.232. So if you consider maybe 100 students, right? And then you want to model number of students will pass more than 100, right? Sometimes your P, because the event success is passing, right? So basically P will be just this value, passing here. Okay, so B. A jar of jelly beans contain 200 jelly beans. Of those, 22 have blueberry flavors. If 18 jelly beans are bought for a jar, find probably 2 of them are blueberry flavor. So here again, this question is a binomial type question, right? So you put out 18 jelly beans from the jar, and then basically like you can model it by find probably the 2 of them are blueberry flavor here. Okay, and the hint here use a binomial. So basically you can see that because 32 has a blueberry flavor, right? So basically like the probability you get a flavor, blueberry, which P will be 32 divided by 200. Okay, so if you randomly pick 1 jelly beans in the jar, right? And you get this, the probability you get a blueberry will be this much, which is 0.16, right? And here you pour like 18 jelly bean from a jar. So basically here like you can model it by binomial. In this case, not exactly, you know, if we follow binomial, because, you know, the 18 is bigger than 5% of the the 200, but because they want you to use a binomial, so it's just so you can also just look at from binomial perspective. So basically, if you know X is a number of blueberry flavor in among 18 jelly beans draw from the jar, right? So basically, at that time, the number of so if you didn't know the number of blueberry flavor, okay, flavor among 18 jelly beans, right? Jelly beans draw from the jar. So basically, yeah, X, if X, yeah, okay. Then yeah, X will follow binomial if you use a hint here, 0.16, right? And success probability 0.16. And from here, like you calculate probably X equal to 2, right? You get exactly like 2 blueberry flavor. So here just a binom PDF function, 18.16, right? 18, which is sample size, success probability 2, right? And then you should get your result with TI calculator, okay? If you go second distribution and you look for binomial PDF, so it'll be 8, okay? The correct choice will be 8. But here, like, actually, this should be modeled by different distribution, but because the hint here in binomial, but so we just follow what's said here, right? Yeah, because like the problem here is like the sample size you draw is not less than 5% of the population, right? 5% of 200 is how many? 5% 200, which you divide by 20, 10, right? 10. So but in any case, anyway, yeah, I just use whatever the hint give you. So, but for sure, for this problem, we can also solve it in the exact way. But it will require different distribution, and it needs to not in the scope of this class. Okay. So in 13, Sam was told his math test score was 2 standard deviation below the mean. If the score approximates normal, what's Sam's test score? Okay. So this score here, it follow maybe X is that score, right? So the test here, it follow a normal with 7.2 and sigma 8. Oh, but his test score 2 standard deviation below the mean. So basically his test score would be 2 standard deviation below the mean, right? So if his test score is X, right? X. So if I do know Sam's score is X, and then because he 2 standard deviation below the mean, which means his z-score of his test is -2, right? Below the mean. So it will be X subtract 72 divided by 8. And from that, you can see that X will be equal to 72. With little bit math, you should be able to get it, right? Okay, so you should get like 56, right? So B should be correct choice. So let's see if we get it correct. Physics, right? Maybe also, yeah, this is another trick, right? 1 standard deviation below the mean. Yeah, maybe faster. 2, which you subtract 2 and you get 56 too. Okay. But either way, you should get the same conclusion. The weekly salaries of teachers in one state are normally distributed with mean this much. And standard of 490, standard 45, probably random selected teacher earn less than 400 a week, right? So if X is the salary, which salary, right? So it follow a normal 490, standard is 45, right? And you choose a teacher, right? And you want to find the probably his salary or her salary is less than 400, right? 400. So 490 in the middle here. So 400 is something here, right? So here basically like it comes back to the problem where you have the value with 400 is a cutoff, and you want to find the probably x less than 400, right? So basically, more or less, you have the value. You want to find the what is the where it stands for, right? What at what percentile? So here in this case, you just use the normal CDF function, right? Array some more number CDF. Maybe put 999, 400, and the mean for 90, and standard 45, right? So if you plug in your calculator, second distribution, normal CDF, and you plug in all this value, or you should be able to get the correct probability. So in this case, they put a negative 1000, but it doesn't matter, right? It won't affect much. 0.023, 0.023. Okay. Scores on an English test are normally distributed, okay, with mean 83.3. Standard deviation is 7.1. So this is a problem. It kind of backward of the 14, right? So you have the normal here, 83.3. Well, you have the standard is 7.1, and you want to find the score that separate the top 10%, right? So here the top 10% upon 1, which means whatever remaining here will be 90%, right? 90%. So basically here just find the 90 percentile value of the English test score, right? So here like nothing else than just the 90 percentile, right? 90 percentile value, right? So basically in this case, you do inward norm function, right? So they have error, you will find the value corresponding to that error, right? So it will be inward norm upon 9 here at 90%, right? You give it the mean and you give it standard deviation, right? And again, you use second distribution and you look for inward norm function and you plug in all this value, you should get 92.4, right? 92.4. Let's see here. So in the interpretation here, you can see that basically for 15, it tells that about 90% of unit test score less than 92.4, right? And 10% will be bigger than this value. In 16, in a study, 78% of adults questions reported that get annual physicals. Okay, a research wished to study the health in people in a certain town. Found probably that 12 adults randomly selected, more than half of them get annual physicals. So again, it is the binomial, the hint here, right? So you survey 12 people, and you basically if you X is the number of people with got annual physical, right? Among 12 adults, right? So it can be 0, 1, 2, 3, up to 12, right? But you can model by binomial. So your X will follow binomial. Well, and success, which means in this case, you define by you get annual physicals. So success probability will be 0.78 here. This is a P. Again, it is the number of people you survey, right? You survey. And you find probably like more than half them get annual physical, right? This means you find probably X greater than 6, right? More than half. 7, 8, 9, 10, 11, 12, right? And here, like, in order to make your calculator process is for you, right? You need to do a little bit of trick here. So which is subtract, right? Add more 6, right? And here the equal sign important for this quick case. And this is how your binomial CDF can function, right? It process the property X less than or equal to a value, right? So this will be basically just a one. Something wrong here with the pen. One subtract the binomial CDF 12, 7, 8, and 6. Okay, 6. And if you plug in your TI, you should be able to get 0.97. Okay, 0.97. 0.97. So the correct choice will be 0.97. Okay. A bank loan officer, okay, 17, raise applicant for credit. The rating are normally distributed between 200 and 150. If 40 different applicants are randomly selected, find the property that they may be below 215, okay? So here, like, the hint is use central limit theorem. So if you notice here, the credit score for people, right? Each person will follow a normal with mean 200 and standard is only 50. And here you just randomly choose a 40 applicants, okay? And you want to look at their mean score, right? And what the central limit theorem tells us is that the X bar here, if you follow normal with the same mean, okay? But standard deviation will be get shrink. So it's no longer sigma, but now it's sigma divided by square of n, where n is sample size. So in this case, your sample size is 50, right? 40, I'm sorry. So this will be your distribution of the mean score of any combination of 40 people, okay? And here, like the question asked you is that like what property X bar below 215, right? So property X bar 215, where X bar is follow the distribution, okay? So again, this become to a binomial CDF problem. I'm sorry, normal CDF problem, because you have the value, you want to find the error, right? Where this value is the cutoff, right? So here, let's say, for example, here, your curve, right? Normal curve here, right? The mean is 200. And you want to find this error, 215, up to 215 here. So this is a normal CDF. Nine, 215, and the mean is 200, and standard deviation is 50 divided by square 40, okay? So if you plug in your TI calculator, the value you get will be 0.9711, okay? 0.9711. You can double check. Okay. 18. A random sample statistics student will ask whether they will take another stat class in the future. Yeah, it's a good question, right? Will you? The resulting 95% confidence interval proportion of students will take another class, 8.27 to 0.33. Is that? It should be higher. I hope. Okay, I hope. Find the sample proportion. So here you have the interval. You want to find the point estimate. So if you remember, we do have the relationship between the point estimate and the interval lower and upper level, okay? In chapter 7, chapter 8, okay? So you should be able to see that basically p hat will be equal to the lower limit, okay? Lower limit plus the upper limit, okay? Divided by 2, okay? So lower limit here is 0.27. The upper limit is 0.33 and divided by 2, okay? So you should get, I believe, 0.3. 0.3 should be correct because these two will be 0.6, right? Let's check. Yeah. Of 132 adults selected randomly from a town to 26 of them smoke, okay? So 26 of them smoke. You survey 132, your N. 26, which is your X, right? Smoke. Construct a 95% confidence interval for the true percentage of all adults in the town that smoke. So here it's just a 1% Z interval, right? You want the 95% interval for the proportion, right? So let me just show you quickly, right? So quickly, DI84, 84. Have a quickly remind. So you have start here. Yes. You want proportion Z interval. So option A here. A, right? Option A. So you actually 26 people smoke, right? Your N is 132. 132. And you want 95%, right? 95%. Which is 0.95. You done, right? 0.129 to 0.265. 129. Is there any option like this? 12.59% to 265, right? So C, right? C be the correct one. Is that a solution? Yeah, that's good. Use the given data to find the minimum sample size required to estimate population proportion. Here the margin error is E. So this is sample size problem, okay? 108. The confidence level is 95%. And you want the sample size needed, right, to estimate the population proportion. So you recall the formula for a sample size is just a cell, right? It's cell, the cell function of the z alpha by 2 square. Because if no prior information available, you just use like p hat 1 minus p hat, but p1 p hat 1 minus p hat, but because no prior information available, so p hat you just like you use kind of flip a coin, right? So it's 0.5. So 0.5 times 0.5 will be 0.25. 0.25 and divided by e square, right? E the error. So 0.08 square. Okay. So the remaining task is finding the z alpha by 2. And recall that the z alpha by 2 here, because you look at the 95% confidence level, right? So which is each side will be 2.5%. This will be 2.5%, okay? So this guy basically is just a z of 0.975. Or if you plug in your calculator, it should be the inverse norm. 0.975. 0.1, okay? And I believe it will be, this value will be 1.96, okay? So now you have everything you plug in, okay? 1.96 squared times 0.25 divided by 0.08 square. Let's see what you get here. Correct here, right? 1.96, 0.25, which is 0.5 square here. Divide. You get a 150 point something, okay? But because you sell it up, so basically you get a point. So after you sell, right, you get a 151 here. Okay, so that's the correct choice here. You can plug it in your calculator and you can check it, right? In 21, it's about testing. Okay, we just get it in the test 4, right? So it should be easy for you. That's the point. The American Dental Association claims that fewer than 50% of adults in the US floss on a daily basis. Okay, so what are the claims here? The keyword we look at. And they look at percent, which is they look at proportion, okay, proportion. And fewer than, okay. So your HA should be P less than 50%, right? 15 less than 0.5. So this testing problem, they will focus on. Always equal sign for the H naught. So C, okay, it's the correct choice. So B and D shouldn't be, right? Because the no has just have to stick with the equal sign. And either A or C, but it's A wrong way, right? Because they say fewer than, they claim fewer than. A scientist believe that American open on average, okay, average more than $15 per day, okay, more than, right, more than 15. So here we look at the mu, right, the mu. So testing problem is that HA, the mu, which is the average number of times they open the door, right, more than 15. and versus the H naught, which is mu equal 15, right? If we test scientists claim using significant level 0.02, what is the following true? Recall alpha type 1 probably back in type 1 error. So first and first, after we specify the problem correct, okay, it's important, okay, because if it's not specified correctly and there's no point of testing, you need to know what you want to test, right? And say like alpha is 0.02, and it's just probably making type 1 error, right? Type 1 error. And type 1 error is the error where you reject the H naught when A not true. So in this case, the probability to reject A naught when A not true is 2%, right? Upon 0.02. And reject A naught, which is you reject mu equal 15 when in fact it equal 15, right? Or in other words, you can also say, you say that you reject a mu equal 15, which means you support, you conclude that mu bigger than 15, right? Because you reject A naught, which means you support HA, when actually mu equal 15. So basically here, like the correct choice will be A, right? There are 2% chance you will conclude mu bigger than 15, or in other words, you reject H naught, right? When mu equal 15, which means when H naught is true, okay? So the correct choice will be A. You have to be careful, okay? I saw a lot of you make mistake in test 4 by choosing the D, okay? The option D. We had a similar problem in test 4, right? If you recall, okay? You should be able to notice that. Given the alternative H1, H8 is the same, P less than, okay, so you test for this, you should know that this is a left tail test, right? Left tail. The P value is 0.0364, 0.0436. Use the 0.05 significant level to state conclusion about the null hypothesis, okay? So with the P value methods, for left tail test, okay, if the P value, right? Oh, but for either test, right? But for P value method, we don't care much about left tail and right tail. We just look at the P value. If it less than alpha, right? You reject A naught. So this is the beauty of the P value, right? You just compare that with alpha, a significant level alpha. So this case, your P value 0.0436, and for sure you see that it's less than 0.05. So which means you reject the null, okay? You reject the null. And when you reject the null, which means you have enough evidence to support the claim, right? So in this case, we call happy ending, right? You suggest something and you collect data and you find out, oh, I can reject the null and I can support my claim, right? The claim here. So it will be C. There is sufficient evidence to support the claim. Okay, 24. Greg keeps track of number of hours he plays video games and the number of homework problems he's able to complete each day for a week. The correlation coefficient for this data is calculated to be R equal to this negative value, 0.2436, right? And so basically, the more he plays the video games and the less homework he can do, right? So something should be expected, right? And here you will see that we should have something negative, right? In negative, the more you play, the less you get for the homework, right? So it shouldn't be C or D, because C, D talk about positive. And here in this case, it will be the weak, right? So we do have the region to say when you have a strong correlation, a linear correlation, and when we have weak, right? In this case, your R is negative 0.2, which we define in a weak error, okay? Weak error. In order to be strong, the absolute value R must be between 0.7 and 1, roughly speaking. In this case, the absolute value of R is just like 0.2, which is less than 0.3, right? So B will be correct choice here. 25, about prediction. The line best fit for data set is y hat equal to this much, right? So the intercept is 102.67 and the slope is negative 0.757. where X the number of minutes spent eating Thanksgiving dinner. Okay. So they and Y number of minutes spent after work. Okay. So they try to predict how long you going to nap based on the time you eat, right? Assume there are strong linear correlation variables. What would be predicted number of minutes spent napping for someone spent 60 minutes eating Thanksgiving dinner, right? So this case, yeah, X is the eating time, right? And you do have the linear regression line to predict that. So you just plug in, right? So basically the Y hat will be equal to time X here plus 102.67, right? And you can use the calculator to get that. I believe if you do that, you should be able to get 68. Okay, 68. 68. Okay. So you can see that it's a kind of, basically everything we have learned in the class. But now we just look at on the whole, okay, on the whole. So for each unit test, it's just about 2 chapters, right? And now we look at on the whole. But in general, I think it's a reasonable ask, right? For this final. So thank you so much for your attention. And if you have any question, please drop by my office either in person or via Zoom, okay? And then we can discuss more. So let's stop here.